sorry about that. This part at the bottom, the last piece, right here, we will do in a separate video. So we're not going to do that today. Now, as far as logarithms go, on a calculator, you have two types usually. You have a base 10, and you have a natural log, a base e. Now, back in the day, before the TI calculators and calculators became more sophisticated, we used to have to use a change of base formula. And we could do that using these formulas down here at the bottom to change from one base to another. Now, anymore, in the TI calculators, they have, and even Desmos has a way to calculate, evaluate without going through that formula. What I have seen occasionally is that that change of base formula does pop its head up. So I wanted to show it to you today. So one way to look at that change of base formula is that basically we're multiplying constant multiples of logarithms with base b. So in this case, if we have log base 4 of 25, that 4 is our a, our 25 is our x. So we're going to convert this to something a little more usable. We will take the log of a, which is 4, and the log of x, which is 25. And we can get a decimal approximation. That's why these little squiggly lines are there. Now, as far as properties of logs go, if you recall, logs and exponentials are inverses of one another. So way back in Algebra 1, you learned properties of exponents, like you see here with the highlighting. And you learned that when you multiply two numbers together with the same base, you add their exponents. So for that reason, with the logarithmic property, we use the same theory. When we multiply two things together with the same log base, we add them. And this is what we call expanding, because we've taken the expression on the left and we've expanded it. We've applied the log to each term. So we have the product property, where multiplication is expanded through addition. We have the quotient property, where division is expanded through subtraction. And we have the power property, which means something raised to a power is the same thing as multiplying it out in front. So what I like to say is that that exponent comes down into the front. And that way, if you could evaluate log base a of u, then you could just multiply it by 10 and you'd be good to go. So here's a couple of examples. They actually do not want us to use a calculator. They want us to write each logarithm in terms of natural log 2 and natural log 3. So if we think about the natural log of 6, we know that 6 is the same as 2 times 3. But using the product property, we can expand that natural log of 2 plus the natural log of 3, because that's multiplication. Here, with the natural log of 2 divided by 27, remember that when we divide, we are expanding by subtracting. So we will have the natural log of 2 minus the natural log of 27. Well, that's already in terms of natural log 2, but we're missing this piece. So what we're going to do is we're going to rewrite 27 as 3 cubed. And if you watch what they're doing, our property, and bringing that 3 down in front, right here, as a multiplier. So we have the natural log of 2 minus 3 times the natural log of 3. Now, as far as rewriting them, we can expand them or we can condense them. So we can make them longer and expand them out, or we can take things that have been expanded and condense them back down into something simpler. So here's some examples of expanding. If you look at part A, we have a 5, an x cubed, and a y. So that's 3 things that are being multiplied. So when we expand that, we expand by adding those 3 things together. And we bring that power down in front with the power property. For part B, we have a quotient. So the first thing that they did was they rewrote that square root as something to the 1/2 power, that rational exponent. And they expanded it by subtracting, because this is a division. Then they took that 1/2, and you'll see why they did that, because they're going to pull that down into the front using the power property.